edited, make sure you look at those edits so that you can kind of see that information there. But again, questions like 18 and 22 with those trig identities, you will not have those types of problem on this test because we're going to go above and beyond that. So you'll be assessed on that later. You have to know the identities, the fact that the reciprocal identity, the sign is 1 over the cosecant, because those we will be applying. But you will not actually do problems like 18 and 22 on your test next week. So in your packet, we are looking at section 4.4 today. So we're getting to the end of the packet. Last section of this portion of the chapter. So we have a couple of concepts just to kind of cover. And then, as I said, next week we'll review. So last section to really do before the first half of the chapter's test. So we've been defining trig functions. We define trig functions on the unit circle. And now we're going to define trig functions for any angle. The difference between the unit circle and any angle. If we are on the unit circle, and I'm just going to write this above, not in that color. There we go. So the unit circle has a radius of 1. And I know I've been referencing geometry a lot, but trig kind of definitely has some geometry in it. In geometry, you really did talk about the equation of a circle, the formula for a circle. You graphed some circles. It may have seemed like that was forever ago, but the equation for a circle is x squared plus y squared equals r squared. The unit circle is special because the radius is 1, and that's what that other value represents. So x squared plus y squared equals 1. That represents the radius. So when it's the unit circle, the radius is 1. But we know that there are other circles that will not have a radius of 1. And that's what we're going to look at for the definition of trig functions. So now any circle has the formula x squared plus y squared equals r squared. So that r squared, the number on the right side, represents the radius. So if I'm on any circle, it says let the angle theta be in standard position, which we know the vertex has to be at the origin and it has to start on the positive x-axis. It says xy is a point on the terminal side of theta, and r is equal to the square root of x squared plus y squared, and it can't be 0. And that's just using the equation of a circle and solving for the radius right here. That's where we get that formula. So we've talked about this before, where we have a point on the edge of the circle, and that point, I would travel over a distance x, up a distance y, and then connect and make a triangle, which is our radius. And then right there is our angle. So you still have a circle and you still have a triangle, which pretty much is everything we've done. We've drawn circles and triangles inside of circles. So if I want to find the sine, and it's not a unit circle, we still know the sine is the opposite over the hypotenuse. Well, if I am given an ordered pair, the sine is the opposite, which is the y, and the hypotenuse, which is the radius. So instead of saying opposite over hypotenuse, when you're given an ordered pair, then it's the opposite side y and the radius of the circle. So we're still defining these trig functions, but we're not using opposite and hypotenuse. We're using y and r. So the cosine then, Peter, would be what?
The cosine is x over r.
And then the tangent would be?
Y over x.
Yeah, notice the tangent doesn't change. The tangent is y over x on the unit circle because it's opposite over adjacent. It doesn't contain the radius in it. So Evan, if I wanted to find the cosecant and I knew the sine, if the sine is y over r, what do you think the cosecant would be, Evan?
R over y.
How about the secant? No, still with you, Evan.
R over X,
And then the cotangent,
X over Y.
yeah, because they're reciprocal. So that's that reciprocal fact. That is that identity, that they are reciprocals of each other. So we can now find values for trig functions in any location still in this circle form. So if you look at example 1, it says find the exact value of sine, cosine, and tangent of an angle theta. So we have an angle theta, it's in standard position. -4, 3 is a point on the terminal side of theta. I think this should be if. This is a Mrs. Kane notation here. That should be the word if. But -4, 3 is a point on the terminal side of theta. So I would like you to draw an XY axis. Whoop. There we go. And you're going to plot this point just like you would plot the point any other time you were asked to plot a point. So this is an ordered pair. When we graph an ordered pair, we move over for X, which is left 4, and we move up 3. So now this point is going to create a triangle for us. And the way that triangle is created is by using the base as our X, which we know we went over -3 or -4. We go up the distance of Y, which is +3. And now my triangle is created connecting the center to the point. So really, there is a circle that is going around this triangle, and that point is touching the edge of that circle, just like we have above. The angle is still inside of the triangle. So how would you find the radius of this triangle, which is the hypotenuse, the radius of the circle, the hypotenuse of the triangle? They're the same thing. Grant, how would we go about finding that?
The hypotenuse, right?
Yeah.
Will we do 3 squared plus 4 squared equals
Yeah.
6 squared?
Yep. So you're still using a squared plus b squared equals c squared, which is really x squared plus y squared equals r squared. They're kind of the same exact thing. We're finding the hypotenuse or the radius, however you want to think about it. But this looks like 9 and 16. It becomes positive once you square it. And then the square root of that is 25. Sorry, the value is 25, the square root is 5. The radius is always positive because it's a distance of a circle. So the hypotenuse of the triangle is always positive because it's a distance of the radius of the circle. The x and y could be negative, and it just is showing you the location of the point. It's not a distance, but the negative is telling us we're on the other side of the xy axis. So they're asking us to find the sine, the cosine, and the tangent. And I think you probably are now realizing that like trig is a lot of just spiraling things through and thinking about them slightly differently. But we've been finding sine, cosine, and tangent since we started this in November. So that first day, or maybe it was it was in November, it was before Thanksgiving. So we started like kind of just little bits and pieces of this. So Darby, what would the sine of the triangle be?
It will be 3 over 5.
Yeah, which is opposite over hypotenuse, or it's y over r. How about the cosine, Darby?
-4 over 5.
And then the tangent?
It will be 3 over 5. Over 4, sorry. 3
Yep.
over -4.
Yeah. And notice now the only difference from what we did on Tuesday versus what we're doing today is that my values could be negative. And it's, again, negative based off the location of that ordered pair. And that's it. Questions? So example 2 is pretty much a review. This one says find the exact values of sine, cosine, and tangent, but they give you an angle. So this one's slightly different from what's above. We were still finding exact values, but the problem above gave us a point. So we found the exact values for sine, cosine, and tangent using the point. These here are saying find the exact values, but they're giving us the angle. And anytime you have an angle given, you can always go back to that wonderful circle. I don't know why it doesn't want to connect for me. There we go. So go back to that circle, draw yourself the angle. This one's 0. Well, 0 would be on the edge of the circle on the x-axis. What is that point? So we're still talking about a point. What is that point if you're on the edge of the x-axis, Peter?
Is it 1, 0?
It is. So then, Peter, the sign would be?
The sine would be 0.
The cosine is?
1.
And the tangent is?
The tangent would be 0.
Yeah. So sine is y, cosine is x, tangent is y over x. I don't have a radius here. I mean, the radius is 1. We don't have a hypotenuse. So draw yourself a little graph, make a sketch. You're still focusing on the point. So whether I have a triangle and I'm finding sine, cosine, and tangent, or I don't have a triangle because it's on the x-axis, I'm still finding that, using that point and finding sine, cosine, and tangent. So try the next 2. Think of the location of the angle. Hopefully your circles are better than mine. I don't know why it doesn't want to work today. It must not be pressing right. There it goes. So sketch the angle, think about that location, but the point on the circle, we're still using that same piece of information there. So the point on the circle, or the point on the circle. Hannah, do you know what the ordered pair is at pi?
Would it be -1, 0?
Yeah. So how does that change the sign value?
It doesn't change the sign, but the cosine
Yeah.
would be
Trick
negative.
question there. What does it change?
The cosine,
Yeah, so the cosine becomes?
-1.
Nice job. And then the last one says 3 pi over 2. So if we have 3 pi over 2, Joe, what would the ordered pair be at 3 pi over 2?
It would be 0, -1.
Yeah, so what's the sign there?
-1.
And the cosine?
0.
And then how about the tangent?
It'd be undefined.
Nice job. Because it is -1 over 0, which is undefined. Good. Questions on that? So still an ordered pair, but because it doesn't make a triangle, we're using that point x and y. So there are 2 other things that we're going to look at. I said it was pretty short. There's one more example below, but then there's this big space here where it says signs of trig functions. And I'm just going to draw an xy axis. When we talk about the signs, we're talking about positive versus negative. So which functions are positive, which functions are negative? And we're going to start with quadrant 1. Quadrant 1 goes between 0 and pi over 2. So any angle that's between 0 and pi over 2 is in the first quadrant. we have a positive x and a positive y in the first quadrant. Because both are positive, all functions are positive. And the key thing here is that every single function is positive. Because x and y is positive, everything involves an x and a y. The second quadrant, over here is pi, goes from pi over 2 to pi. So any angle that's between those two values is located in the second quadrant. Darby, what do you know about the ordered pair in the second quadrant?
The x is negative, but the y would still be positive.
So if the y remains positive, which function deals with y?
The tangent and cosine.
The tangent and
Or
cosine?
sine. Sorry.
Sine, yeah. So the sine specifically deals with y because it's y over r, where the tangent uses y and x. So the sine and its buddy, the cosecant, would be our positive functions. Everything else is going to be negative in the second quadrant because it also contains an x. So cosine is negative x over r. Tangent would be y over negative x. So the sine and cosecant would be positive. Every other function is negative. Going into the third quadrant, doing the same thing. This is 3 pi over 2. Goes from pi to 3 pi over 2. And negative x, negative y. So x is cosine, well, cosine is going to be negative. Y is sine, well, y is negative. But tangent is a negative y over a negative x. And if you take a negative and divide it by a negative, that means our tangent and cotangent would be the positive functions. So if your angle is in the third quadrant, your tangent better be positive because both x and y are negative, creating a positive value. And then the last one, we know for all the way around, we're at 2 pi. And we also know that now we have a positive x but a negative y. So cosine and secant would be our positive functions. So everything is positive in the first quadrant, sine and its buddy cosecant in the second, tangent and cotangent in the third, and then the cosecant and the secant in the fourth. That's a way for you to kind of just check your solutions. So what quadrant is it in? If it's in that specific quadrant, then that function should be negative and everything else should be positive and everything else should be negative. So the last example here gives you a tangent and it's equal to negative 5/4. And then it also says that the cosine is positive. Find the other trig functions. So I like to start off with the graph, a little drawing. So they're not giving us an ordered pair, but instead they're giving us the tangent, which we can think of as an ordered pair. So it's telling us that the tangent is negative and the cosine is greater than 0. We know that the tangent is y over x. I also know that the cosine is x over r, and it's saying that has to be positive. So my x is going to be positive, but my y, the tangent, is equal to a negative number. So if tangent is y over x, one of those values has to be negative. Does anybody know which one of those values is negative? If it's -5/4, Peter?
It would have to be the y.
Yeah, it's going to have to be the y because cosine, it says, is positive. Cosine is greater than 0. So that point, my y is -5, my x is 4 because they're telling me -5/4 is tangent. Well, that ordered pair would be 4 and -5 because tangent is really an ordered pair, y/x. So now we're going to plot that point just like we did with the first question. 1, 2, 3, 4. So you have to kind of use a little bit of reasoning skills here. What are they giving you? How can I use that information to help make a sketch, make a diagram? So we have over 4 down to -5. That's where my point would be. And then I can make a triangle. Trig is the study of triangles. I think in most of the problems we've drawn or completed, we have drawn some type of triangle for it. Make sure that that angle is still in there, always connected with that origin. It's a standard form. It's, you know what the calculator is? I think it's on the table. But here. But your calculator, I think, is, look on the bar. Sorry. Remember, anytime you square a negative, it becomes positive. So we have 16 and 25. Can you break down the square root of 41 at all? No, it doesn't
No.
break down. So what does this say to do? Find the other trig functions. So we have our diagram drawn. Find the other trig functions. So we need sine and cosine. They gave us tangent, but we also need the cosecant, the secant, and then the cotangent. Does anybody have questions? Am I going too fast? Everybody's all right? If you have a question and you're hesitant, like send me a chat, please let me know. So sine is opposite over hypotenuse, or y over r. -5 over the square root of 41. Which if I rationalize, -5 root 41 over 41. The cosecant would be the flip of that. So -root 41 over 5. Remember, they're reciprocals. The cosine is going to be adjacent, or x over r. This one's positive. It told us in the problem it should be positive, and it's positive because my x is positive. So root 41 over 4. How about 4 root 41 over 4? There we go. Get it right. And then the cotangent, well, we were given tangent as 5/4, which is negative. So cotangent would be -4/5. Are there any questions? So we're still drawing a triangle. You're still using Pythagorean theorem, but that triangle now is located in a specific quadrant. The quadrant it is located in is based off of whether x or y is negative from the given information. So when you sketch your triangles looking at the homework, make sure you're sketching your triangles in the correct quadrant location. So move over for X, label that value, go down for Y, create the triangle. Still thinking that there really is a circle. There's this invisible circle going around my triangle. That point is still on the edge of the circle. So there you have 10 minutes. On Google Classroom is a little quiz posted for today. There are no quizzes next week because we have a test next Thursday. So no quizzes next week. We're going to kind of wrap up section 4.4 next week at the beginning of the week. Did it post? Do you guys see it?
Yeah, it's there.
Yes, it's there. Okay. So the first question, supplementary. The second question, the exact value of tangent. So I would suggest sketching a circle, finding that location, sketch the angle, and think about what is the X and the Y of that value. And then the question 3, sketch the angle, label the point on the circle, and then find the values of the functions that are listed. But I strongly suggest for number 2, like drawing your circle, getting that point, and using the point to find tangent. So this one focuses a little more on ordered pairs than the previous quiz. If you have questions, please let me know.